Welcome folks to this xShape demo where we make the shape for a remote control. First I'm going to make a new component and name it Remote Control Master and put it in my collaborative space. Then I'm going to go to Features and create an origin if I need to. We're going to sketch with similar functions to SolidWorks. Simply create a line, use Control Select to mate it to the origin midplane. And simply clicking has the instant change toolbar, and we can simply click to make a dimension. Familiar tools like Sketch Picture, where we're going to bring in a picture for the remote side view from the Industrial Designer and adjust it to make sure that it fits within the bounds of the line that we just created, just as we would in SolidWorks. We're going to do the same thing with the top view as we did with the side view by increasing the transparency and adjusting it to the line that we originally created. When we like the placement, we'll hit the green check, save it, and then we're going to choose the subdivision feature. We have 2D and 3D subdivision primitives, whatever digital Play-Doh shape you think best fits. I think a box will work fine for this. Place it on the origin, mid-plane. We can scale it to oversize, and we can also drag the robot arm in both directions, and we're going to oversize this digital Play-Doh blob. And so we can add loops here. So I'm going to add some extra loops for control in along these planes, but we can always add loops while we're designing as well. So automatically going to knit this into a solid, and I'm going to hit the transparency button and beef up the transparency so we can see the sketches on the other side. We can manipulate this with the surface, the cage, and the surface, or just the cage, but we're going to start out with the cage and the surface so that we can do the overall balance and use symmetry. About the ZX plane, utilize the bounds of symmetry. Dragging our mouse over the vertices allows us to select them. And there's even a toggle to select just the visible elements, but we want to select all of the elements in this case. So once we have the overall bounds of this shape bounded, we'll switch over to the surface and start manipulating the subdivision primitive to better fit that shape. I like to go from each side, so once you select the vertices, a robot arm will appear. A right mouse click allows you to change the orientation of the robot arm, and dragging on the handles allow you to move them, and dragging on the bubbles allows you to scale it in that direction. So here we're just going to look orthogonal and adjust orthogonal to the screen. Sometimes it is nice to use the selection mode because we like the robot arm to be normal to that surface. Now if I need more loops because I need more control, I want to control all the inflection points. Filter edge, use perpendicular edge, and insert the loop inside there. And then we're just going to adjust this shape from one side to the other. We can use the spline tool to hold left click and drag in the direction we'd like to go. And we can always use Control Z to undo, or use the undo function. And we can also adjust with a line tool as well. I need to adjust these points here, so I'm going to use the line tool from the instant change toolbar to help smooth out the curvature in this area. Now onto the top view. We can align vertices to each other. We can align subdivision elements to each other. We can have other geometry in here and align to that as well with our alignment tools. There's a flex tool and a scale by distance tool. Let's see scale by distance. Just grab the vertices you want to scale and put the scale in. Use the flex tool to use the flex line to grab your vertices, and then use the robot arm to make some more subtle, flexible manipulations to those points. There's an arc bend tool. We'll grab the plane we want to bend about, select the vertices we like to bend, and use the robot arm to make rotations, or very light rotations, in the model. And we're simply just going to adjust from one side to another. And once it processes, it becomes a solid, and now we have our solid shape, and we're just going to buff out the creases, and we can add material. If material's on both sides, it makes a cut. And we can even subdivide this area to add more control for a keypad outline. So by filtering edges, I can adjust the edges and get the edges around the keypad area here that my industrial designer made, so that we can make this flat with the crease tool to put buttons in this area. So we've added more points of control, more vertices, and flattened that keypad area on the top. We can cut this in half if we need to, if it was fully symmetric, and it would become a surface model at that point. If it doesn't knit into a solid, we can check by looking at the section view. We can also delete faces on the subdivision element. Each one of these faces are able to be deleted. So we can delete those faces, we can fill those faces back in, and if we see any creases, like we see in this area over here, we'll just buff those creases out, and it should be able to knit back into a solid with the knit surface, as we can see with the section view. Now we're just having fun adding some more extrudes, and if those extrudes were on opposite sides, it would create a cut. And of course now it looks more like a football cleat. And when I'm done manipulating everything, this is what my final shape looks like. I have the flat portion on the top for the keypad outline, and then we're going to take this body, we can take it into SolidWorks if we need to, split it, and make it a remote.